one of the important adaptations you'll notice in alpine boreal forest is this situation right here. You'll notice, like there in Texas, North Texas, there is some evolution to ice. We do actually have ice, and you can get layering of ice on tree branches. Now, where I went to forestry school down in Nacogdoches, and further south than that, headed toward the Gulf or headed over into Louisiana, you're on the other side of what we call the ice line. Ice, you really don't get below freezing temperatures and heavy ice or snow coverage in those places. So the organisms are not adapted to it, but here they are. So you'll notice the branch comes out at almost a 90 degree, right? But then it goes down. And that's for this right here. It's because it has evolved to the snow coverage. So this snow is eventually going to, as it gets heavy, watch, right? So as it gets heavy, laden with snow, then it will shed its own snow and then pop right back up, and it's not going to break the limb, which is what happens to our native hardwoods when they get covered in snow and ice. It just starts breaking the limbs off. It can't support the weight. It has no evolution to dump its own snow and then pop right back into place. The elasticity and things are not there. So again, to prove my point about snow and ice and how integral and important it is to maintain snow and ice in places where there's supposed to be snow and ice, is because all the organisms are adapted to it, right? Look around me in the background. Like every one of these organisms, all these plants, even, I'll find an aspen in a minute, but all of these trees are all snow adapted trees. Of course, you can see the snow all back through here. And I'm gonna get down a little bit and hopefully show you. It's tough because the sun's been up for a few minutes now. It is only 28 degrees, but solar radiation is much more intense in the mountains because there's literally less atmosphere between me and the sun. I am literally closer to the sun, and there's less molecules between me and the sun. So as you can see, the difference between sun and shadow in the mountains is extreme. All right, I'm gonna have to drop some elevation a little bit to get down in here, but this is sort of the formation of an aspen grove that's starting to form right here on the side of this cliff here. Now, all of these are young aspen trees. There's a little bit older aspen trees over there. But anyway, believe it or not, these organisms are all connected by the root systems. It's fascinating how aspen trees do this. But what I really wanted to talk about was snow loading. So you see up here, you notice the aspens have already dropped their leaves. Now, part of that is because it does get so cold here that it'll destroy the leaf. But it's better for the tree to pull all of those chemicals in and store it and go ahead and drop the leaf and dispose of it and put on fresh leaves later. But here's the other thing, is if it was to have a bunch of big leaves on it, it would hold snow, and these limbs are not adapted to hold huge amounts of weight of snow like this tree here is, or any of these others. Now, so it would just be shearing the limbs off. So again, this is an adaptation. This is all exactly the way it is supposed to be. It is all working exactly the way it is supposed to work, which is beautiful.